Alright, welcome to another horrible day in the neighborhood. It's a horrible day in the neighborhood, a horrible day in the neighborhood. Would you, eat shit and die? You fucking dumb cunts. Anyway, it's gonna be one of those days. Oh, God, I just hate this planet. Anyway, so this scumhole piece of shit retard, the Spars lab. Yeah, some lab. Fucking douche. Can't do anything precisely. Anyway, so he's got a proof. Simple ways to prove the unit of acceleration is meters per second. I don't know. Slash seconds. I don't know what that means, right? What the hell does a slash seconds mean? So that's what he writes in the title. Why don't you just say acceleration is, two units of acceleration, times itself. Just too stupid. So, let's go over it once more. I mean, even a little kid should be able to figure out what they're saying doesn't make any sense, Gary. How can they keep saying something so fucking stupid? Well, it's a free country. That's how, I guess. It's a free world. You're allowed to be a fucktarded idiot. Nobody's going to pass a law against it. Except me. I will try. Yeah, that's what'll happen. Alright, so you have a simple scenario. Gravity provides you a rather simple way to just watch something get affected by a force. Okay, so there's a simple rule. There's going to be a force. It's going to be affecting the little object, and it's going to cause an event to happen. And all events actually happen over a period of time. Not big news. Alright, so Newton, long time ago, found out it's this 9.8 thing, but we're just going to call it 10 for the fun of it, okay? So it's 9.8 meters per second of acceleration. Okay, it's really just a velocity, right? Okay, when you start from nothing and you're given this thing called an acceleration, the acceleration just means your velocity. The velocity and the acceleration are exactly the same in the first instant. Okay, so every time you go, see this seconds part here means every single time one of these second things goes by, and let's just, for the sake of argument, say we have a circumstance where we have nice round numbers of just 2 seconds. Okay, what's going to happen in those 2 seconds, right? And we have another thing we can compare it to. We could compare it to an event that's only going to take 1 second, okay? So we have an event that'll take 1 second and one will take 1 second, but this will be add another second to this one. All right. Well, I probably should do it. A nice head-to-head comparison. Okay. So we're going to do 2 experiments. One that'll stop after 1 second, and one that'll stop after 2 seconds. So we're only going to have 2 units of time involved. All right. Now, like I said, even the little kiddies could figure out that, okay, 9.8. So this gets this 9.8 thing. Okay, so it's going, let's just say 10 meters per second. And this one, it's got the 9.8 to 10. And it's going 10, okay, meters per second. Okay. Per second. Let's put a little line there just for fun. Okay, so that's what it's doing. That's its velocity. Okay, the rate at which it's moving now. Okay, and like I said, the one we're stopping it. Okay, so that's all it gets. That's all there is. There isn't anything more. Just 10 meters per second velocity. It got it. It only traveled 5 meters, by the way. Okay, it took, because it doesn't get the acceleration is happening in little tiny pieces. It takes a while for it to acquire the full amount. A full second, actually. All right, so the second one's now going to be given another hunk of this. I should put this 5 here, just confuse people. Okay, So it got the 10 thing. It got 10. And this is what 10 does, this much distance. This is how much distance you get from this acquisition of this stuff per second. All right. And so you get another one. All right. So this one's going to get an extra one. I should have done that one. It doesn't matter, though. All right. So this one's getting 2 units of 10. All right. Now, Galileo, 500 years ago, proved, yeah, it's only going 20 miles an hour. Okay, I got 10 plus 10 equals 20. That's how fast it's going. That's all. Because it's only 2 units of time. Now, the trick is, okay, in this unit of time, because it was already going 10 this way, okay, because it was already going 10, all right, see, this one just stops here. Because this one's already going 10, it means that, wait a minute, it's going to go further because it has the extra velocities. It's already still got that extra velocity. So it's going to go more. Now, again, this is where the 5 comes in, because you have to first kind of understand that the 10, okay, acceleration, only gives you 5 meters of actual distance. Okay. You only get 5 meters of actual distance when you get a unit of 10 velocity. Because again, it takes you a while. You're going slow, and then you're finally ending with the speed. And so you're not going 10 when you start. You're only going 1, and then you're going 3, and then you're going 5, and then you're going 7. So it takes you a while to get up to the 10. And so that's why you don't travel the full 10. So you only went 5 in real falling distance. Right? So the 10 only gave you really 5. It only gave this one 5 too. So this one only fell 5 distance. It's only the distance, you know. That's only the distance. And what is it? But you're going 10. So now you're going 10, and now you're going to add 5. So essentially, this is what you end up with. And so what you end up with, okay, when it falls 2 seconds, is that you get the first unit of acceleration, and it only produces this much. So it doesn't matter if you're going 700 miles an hour here. All you're going to get for another second is this, okay? That's the only thing the new unit gives you. It only gives you the 5. You only get 5 meters of distance from your 10 meters of acceleration. So this is the only thing the force actually did. The fact that you're already moving is the part that you're accruing, you're acquiring, is the fact that you're actually going the velocity. So it's not really the acceleration that causes you to go much further. It's the velocity that was a consequence of the acceleration. So the fact that you've already acquired the 10 here means you'll travel this 10, okay, plus the 5. So in the second unit of time, right, you're going to go the full 10 plus the little 5, which is going to be 3 units of 5. So you went 5 in the first, and you're going to go 15 meters in the second. And then you just keep adding that up, okay, to get bigger and bigger numbers. So that's what it is, okay? It's, and this idea that it's per second, well, you know, obviously it can happen for 2 seconds, or it can happen for 10 seconds or 7 seconds. If I square, you know, if I write this as 9.8 meters per second squared, okay, that isn't saying per second. That's saying square 9.8. That's saying 100, okay? There's no 100s anywhere in here. Okay, there's no squared 9.8s in here anywhere. All right, all you're going to end up with when you go twice the time, you'll end up with 2 times the time, only twice the velocity. That's all you're going to have, the 19, you know, 20, and twice the weight. So even though you fell 4 times as far, you're only going to weigh twice as much. All right, and that's the reality. And like I said, these morons keep arguing for this other crap even though they have no evidence. I mean, literally no good, credible evidence to defend this wacky, silly nonsense they're saying. They just keep defending it. Why? because there are some kind of, have some sort of philosophical notions that are incompatible with this, this physics is too atheist. It does something they don't like. So just like Leibniz originally, they're dissatisfied with physics that explains something simply and without any bullshit. And they need the bullshit. They want the woo to be true for some kind of personal, religious, wacky, philosophical reason. It can only be called a religion, frankly, fairly, because it is woo. It's some sort of unproven, undemonstrated, made-up, fucktarded wormhole kind of theory, and they really need their wormholes to be real. So I don't know what this asshole's particular bent is, but obviously, why would you defend a theory that doesn't have any evidence? Obviously, you have to have some motivation to do that. It's like trying to convict somebody who's innocent of a crime. Well, you must have some kind of reason to do that. Moron. With an agenda. Morons with an agenda.
All right, let's do another video on.
Oh, yeah, big fun. I like to speed it up, but his accent's probably harsh enough to make that impractical. Play.
Velocity versus acceleration and their units, and why there is actually absolutely no mathematical problem to use the unit of acceleration, meters per second per second.
Okay, why there's no problem squaring the rate of acceleration for no good reason. As if somewhere in the equation you have 10 times the outcome. Somehow the effect is 10 times. So you have something that's happening, 9.8. That part's figure-outable. The meters part makes sense. Okay, it's 9.8 meters. But obviously, okay, it's an acceleration, so you don't get 9.8 instantaneously. You have to accelerate to 9.8, so you really only go 5 meters. Okay, you get that part. But where's the square come in? Why would I square that rate? Even if I square the actual distance, 5, I get 25. Nothing went 25. There's no 25s anywhere. It's stupid.
All right, I have a very simple way to understand this. All right, let's start with velocity. The unit of velocity, meters per second. All right. And we're going to...
It's the way you measure velocity, okay, is to have to do it in some other way. But yes, the velocity is a specific event in the universe. It's a function, something traveling a velocity. It's covering a distance in a unit of time. That's how we measure it. But the velocity itself isn't a distance in a unit of time. You can sort of understand if my hand's moving. It's the distance and the time are not what my hand's doing. My hand actually has something that enables it to move a distance in a unit of time. It doesn't do it because there's distance and because there's time. It does it because it has a quantity, the 9.8. It has a velocity. And all acceleration means is you're changing the rate of that velocity. You're taking away some velocity or you're adding velocity. That's all it means. It's not some special thing. It just means that the quantity of the motion. See, maybe, at first, for all of my life, the idea of Newton and Galileo and Descartes saying quantity of motion, that wasn't very intuitive. It was kind of a sloppy way to describe things, right? They didn't have the word momentum back then. And it just seemed awkward and didn't seem right. But now I'm seeing the logic of it because it's so precisely saying exactly what you want to say. There's a quantity of something that the object has that gives it motion. And that quantity ends up being a derivative of mass and velocity.
What we're going to do is we're going to replace...
A product of mass and velocity. I shouldn't say a derivative. It's a product of mass and velocity. That's something like... The idea is that the mass is the bucket and The velocity is the force being held by the buckets.
Replace the m and s with a number. Let's say m is 10 and s equals 2. All we want to do is understand the units and the outcome of the units. And we're just going to replace it with numbers to perfectly understand logically, mathematically, why the units make sense. All right.
Okay, so then write down 9.8 meters per second and explain why it's per second per second. You won't be able to because it means you just squared 9.8.
So now we can say that, yeah, the meter is a unit of distance, second is a unit of time. So we have velocity equals...
I mean, you already had it in meters. That's more specific than the D. So now you're generalizing from meters and seconds to any form of distance and any form of time. You know, hours, days. Why would you break it down to make it more general? You don't need to do that. You've already made it more specific. Why make it more general?
Distance divided by time. This is a formula that we can use to calculate distance. And
so you can use it, but rational people wouldn't use it because it doesn't mean anything. You don't know whether it's hours, days, months. You don't know whether it's feet, miles, parsecs. It's useless mush.
Velocity. Blah. So yeah, unit of velocity. So yeah,
let's see, I put the. No, I didn't. Okay, so I'll put that back up. Sorry. Well, you're not missing anything, obviously.
Equation is already in its unit. Meters divided by seconds. Those are units of distance and time. Meters divided.
So again, I don't need to divide meters and seconds. I'm saying you're saying the units are meters per a second. Okay, so the idea is it's a certain number of meters. That's established. You don't need to divide it. You know. Realistically, how is dividing it going to help you any? I mean, if I divide 9.8 meters by the number of seconds, then I'm just going to start shortening the number. I'm going to keep making the number smaller and smaller. So why would I do that? Meters seconds is not, dividing the meters by the seconds.
Divided by seconds, distance divided by time equals velocity. All right, velocity equals meters divided by second equals distance, which is meters divided by time, unit of time equals seconds. So yeah, meters per second equals meters per second. Let's say we have 10.
Okay, so that was very useful, right? That meters per second equals meters per second. Gee. Insanely. I can't believe nobody drew that for me. It's so obvious. 1 equals 1. 2 equals 2. 3 equals 3. Yeah. Boy. Was my education ever lacking? Nobody drew that on a board before. Fuck.
That's m for 2, 10 for m, and 2 for s. So which is 10 divided by 2 equals 10 divided by 2. 5 equals 5. No problem. It's the same.
Right. But what does that mean? The acceleration was 5? What the fuck does that mean? That doesn't mean anything. What did you just solve for?
All right, let's go to acceleration. If we want,
I mean, if you're going to say that, yes, you want to know how far did it travel, 5, well, that would work, okay? It only went 5 meters in 1 second. And then you're going to only accelerate another 5 meters in the next second. You're not going to accelerate any more than that, just 5. So you have a total acceleration of 10, if you add it up that way, all right, which is only twice as much as what it would get in 1 second. It's only twice as much force. I mean, again, it's only twice as much acceleration. This is only 2 units of time.
want to know what the velocity is after a certain amount of seconds, then we do velocity equals acceleration times time. Let's say our acceleration.
So where's acceleration? Yeah, so you haven't done acceleration yet. Where's that? That's not in here.
Acceleration is 10 meters per second. So we are gaining 10 meters.
I mean, again, it doesn't mean anything, right? Because we know if it already has a velocity, that's not going to mean anything. So in the first second, if it gains a velocity, then the velocity is already a different number. But let's say where he's going for the total acceleration, which would be the net acceleration. Then Newton made it clear that you don't need this a times t thing, right? Because it's just your momentum. Changing your momentum, that's your fucking goddamn acceleration.
Per second every second. After 3 seconds, our velocity will be 30 meters per second. Now I understand that initially you would say that the only thing you have to do is take the velocity and do it times the amount of seconds.
There you go. That's it. That's right. That's the correct answer. That's exactly what that means, 9.8 meters per second. That after 3 seconds, you've gained 3 units of 9.8. That's exactly what it means. That's rational math. And as soon as you do something else to make it some other number, you've broken that, which is consistent and real. And so you must be doing something not real.
If we are having an acceleration of 10 meters per second, your velocity after 5 seconds will be 50 meters per second.
50 meters per second? I guess he said 5 seconds. Okay.
So the only thing you need is 10 meters per second times seconds. There's no need for 10 meters per second per second. But let's take a closer look at it.
Why? You just point out how, yeah, that makes perfect sense and it actually gets the right answer. So why don't we just stop right there and say, yep, got it. Got the right answer. I mean, that's what it comes out to being. It's only twice the velocity. It's only twice the weight. It's only twice the time. It's all these twos are sitting there right there saying to you, oh, the 4 doesn't mean much because, yes, the fact is the higher velocity means I cover more distance in the same amount of time. Time isn't the same in the sense that the distance, the meters per second, will not be consistent. So I can't just draw a formula and say it's all the same stuff. The variables are the same. No, the variables are changing as the experiment takes place. So you can't just write this simple formula and say it's always the same distance and it's always in the same time. Well, yeah, you can say it's the same time, 1 second, but the distance clearly won't be the same.
And it will make sense. So we have velocity. V equals a times t. Velocity, the unit of velocity is meters per second. Meters per second equals the unit of acceleration, conventionally speaking, is.
So whatever that means, right? Now, our velocity doesn't mean a unit of acceleration. It really doesn't. I mean, just doesn't, okay? I mean, the unit of acceleration is an amount of something, and you can only have that same amount. That amount, that amount, that amount, that amount. You just add up how many times you got the unit.
Meters per second. Per second. Times time, unit of time.
All right, so what the hell this is? I don't know. He's saying meters per second equals meters per second squared. So let's understand when he says second per second, he's saying second squared. He's saying you're supposed to square the seconds. You're supposed to square the number of the meters, actually.
Times second. So this is it. Meters per second equals meters per second times seconds. All right. Let's replace them with numbers. 10 for s.
So whatever. So this is his simplification. So he writes something meters per second in this form that isn't any form I've seen. Okay, and then says per second as if I'm supposed to know what that symbol means. What are you doing? Again, I don't. If you divide meters by seconds, you're not going to get an answer to anything. And if you divide it by seconds again, what answer are you getting? What number are you getting? If you had actual numbers in here. So you said, let's put real numbers in. And then you stopped saying, let's put real numbers in. So go ahead, put real numbers in and do that math and tell me what the fucking answer is. And I'll tell you those two things aren't going to equal each other. Okay, meters per second is not going to equal meters per second times 5. Or whatever that is.
M and 2 for s. So m divided by s, 10 divided by 2 equals 5. All right, let's do it like this. Equals meters per second. 10 per 2 per 2. 10 divided by 2. Again divided by 2.
So he's saying squaring something. Saying meters per second squared is the same as saying divide 2 by 2. Now, if I was doing that math, I would just cross the 2's out myself, personally, the seconds. Because I don't see what use those units would have being divided into each other.
Times 2. Right, next.
Yeah, so if I just kill these 2's, then I have exactly what I want, which is 10 times 2. Yeah.
Step 5. 10 divided by 2 equals 5. 10 divided by 2 equals 5. Divided by 2 equals 2.5. Times 2 equals 5. So 5 equals 5. Remember?
And what does that have to do with how you write the math? Okay, you don't write this math. This isn't written anywhere. You write second squared. I mean, because you put this fake 2 down here, you end up saying, well, let's inverse and multiply or some other kind of crap, and then end up multiplying the seconds times the seconds. Even though they're 2 different units of time. The unit of the distance and the unit of acceleration is different than the, the unit of the other unit of acceleration. And so the 2 don't have the same time.
We are now calculating the units, but we have just replaced them with numbers. And so this unit 5 equals this unit 5. It's the same. Velocity, so which means that acceleration times time equals velocity. Meter.
But it's not how it's written. So you can use, well, you're going to keep saying it, but you can keep saying it all you want. But what you do is put a squared symbol on an object. And the squared symbol means you just multiply the thing times itself. And that ain't going to work.
Meters per second times seconds equals meters per second. And that's mathematically correct. Now, in mathematics, we can do stuff like cancellations. So we have 10 divided by 2, divided by 2 times 2. Divided by 2 times 2 cancels itself out. It's 1. Divided by 2 times 2 is 1. We can cancel this and this. And we are left with this.
Why don't I just cancel this other 2? Yeah, why didn't I do that? Because the fraction was fake in the first place. Okay, it's a fake fraction.
Because 10 divided by 2 is a...
It's supposed to be a 1. It's not a unit, right? So when you put something over, say you have to multiply 5 times 2/3, and you want to turn them both into fractions. Well, you put the 5 over 1. You don't put it over 5 units of anything. You don't do anything like that. You just put a 1. 1 of this. That's it. Just a 1.
Already 5. We don't have to divide it by 2. 2.5 times 2 equals 5 again. We already have 5 here. 10 divided by 2. So we can delete this, and we're left with 10 over 2 equals 10 over 2. Same way, we can cancel this, or delete this, and what we're left with is meters per second. Meters per second equals meters per second. Velocity equals...
You're right, and we could just see, and then you say, I can put another meter, divide by meters per second, I can put another one in there and it's still equal. So I'm just saying, you can't see how that can't possibly be true. That it can't be the same number if you divide it again by something. But whatever, go ahead and play the game.
Acceleration times time. Acceleration, meters per second times seconds equals meter per second. And that's what we want. We want to know the velocity. We have used meters per second times second, and that equals meters per second. All right. So what about meters per second squared instead of per second? Let's do that.
Yes, please.
So we have, again, meters per second. Velocity is meters per second times acceleration, meters per second squared, which means times itself, seconds times seconds. So meters per second times second squared.
Why is that
itself, times seconds?
No. Why is that in here? Why is seconds times seconds going into, dividing into the meters? Why is it doing that? Yeah, sorry, I'm just saying that doesn't give you anything called a rational answer. Especially for a velocity that you're adding to, okay? It's certainly not going to tell you how far you went and give you the right answer, so that's not right. It's got to be multiplied, but okay, go ahead, play your game.
Again. Okay, let's replace them with the numbers again. So you get 10 divided by 2, which is 5, equals 10 divided by 2 times 2 times 2. Okay. That equals 10 divided by...
All right, 10 divided by 4, which is 2.5 or whatever, and times 2 would be back to 5. Okay.
4, which is 2.5, times 2 equals 5. So we have 5 equals 5. Unit 5 equals unit 5.
Right, so it doesn't matter whether it's meters per second or meters per second squared, somehow you get the same answer. What? Yeah, no. Too silly.
Again, we can do cancellations. We can cancel this, because 10 divided by 2 times 2, that cancels out.
Well, obviously it's not the units squared, so that's part of the fakery here. It's 9.8 meters. That gets squared by the second square. The last square really is just saying square the whole thing.
It's just 1. Then so we can delete this. We're left with 10 over 2, which is 5 already. We don't need to do times 2 and then we don't need to do the next part divided by 2 and times 2. They cancel out. So in the same way, cancel out. Meters per second equals meters per second.
All right, so again, I'll just argue that this doesn't give you, okay, if I divide the meters by the number of seconds, what answer am I going to get? So it says 9.8. All right, so let's say it's 10 meters per 10 meters per second. I divide 2 seconds into 10 meters. I'm going to get what? I'm going to get 5, right? 2 seconds and I only went 5. It doesn't make any sense.
So acceleration, meters per second squared times seconds equals just meters per second, and that's mathematically correct.
You can say
it.
it.
So now let's say that.
And I'm just going to argue it's not mathematically correct, because what the fuck are you doing here? I mean, why would you? How does this work? You just explained to me how this actually gets you the right answer for what your velocity is going to be, which it won't.
Second squared, we don't need meters per second. We only need meters per second, which means we delete this, and this becomes just v. V equals v times t times time. Because yeah, it sounds intuitively logical to say
the rate times the time. Right? That's all there really is. So if you want to say your velocity is in a rate, okay, 60 miles an hour, how far you'll go will be that rate, 60 miles an hour, times whatever units of time you have. So 10 units of time, then it's 10 times that rate. But it's not the rate squared. So again, you're putting a square on the rate, not on the time.
If you want to know our velocity after a certain amount of seconds, and let's say our acceleration is 10 meters per second every second, we are gaining 10 meters per second every second. So after 5 seconds, we have 50 meters per second. So if we want to know what our velocity is after 5 seconds, we only do 10 meters per second times 5 seconds. All right? See that? So which means velocity times time. Let's take a look.
You keep saying it. The velocity is a rate, and the number of times are the units, the times you did that rate. It's not the rate squared. So again, it's not what you're saying. Your formulation isn't saying that. Your formulation is saying square the rate.
At the units, so we have meters per second equals meters per second times seconds. Let's replace them with numbers.
again, it says there's no point, right? There's absolutely no point. Right there, you're just saying, okay, we teach this to a kid, that these two things that are clearly different, you're just multiplied times something. Okay, and if it's not a 1, then you're fucked. Because you can't get the same answer. Shit.
So 5 equals 10 meters per second divided by 2 times 2 equals.
So it would be 10 meters per second, not 10 meters per second, whatever this divided by thing is. You're not dividing by the number of seconds. But whatever. I'll keep saying you're not going to get the right answer. So put real numbers in. You're not going to get the right answer.
10 divided by 2 equals 5 times 2 equals 10.
After 5 seconds, you're not going 10. And after 10 seconds, you're not going 5. So
we are left with 10. And 10 is m. We are only left with meter, but no meters per second. The same. We have divided by 2 times 2. That cancels out.
Well, so now he's canceling out the 2. So you can see the chicanery, right? So when he drew this fraction before, okay, he couldn't cancel out this denominator with this numerator kind of thing. Okay, but now he can. So that's the bullshit. I would have canceled them before when you were canceling this. I would cancel this s with this s, yes. The denominator s would cancel out with the other denominator s.
We are left with 10. Same over here. This cancels out. We are left with m. So if we do
5 equals 10, whatever, I don't know. That helps somehow.
meters per second times second, we are left with meters. Just a distance, not a velocity.
And it isn't accurate, okay? Because what the hell could that possibly mean? You're not gaining 10. It's 1, 3, 5, 7. You're gaining a lot more than that, so that's not right.
So that doesn't make sense. That's it. That's all I can give you. It's probably the most simple way to, yeah.
Why is it simple? I'm just asking you, okay? I don't think it makes anything simple, and it's not accurate to how they write it when they write it in a formula. It ends up being 9.8 meters per second squared as the acceleration. So you're squaring the acceleration. You're squaring the rate. There's no reason to square the rate.
Mathematically understand this, or mathematically understand.
Yeah, there's nothing. Yeah, if that gave anybody any mathematical understanding, again, the velocity isn't how you measure the velocity. So the velocity isn't distance divided by time. It isn't. Okay, it just isn't. That's how you measure it, with an arbitrary distance and an arbitrary amount of time is what you use to measure it. But it's not distance and time. It's made out of. The velocity is a quantity. It's just a number. Related to how many meters you'll travel in a second. Anyway, let's see what the old Godfrey says. Deleted his last comment. I'm just saying, but the rate is so obvious. It's sitting there telling you this is the rate number. Why would I do anything to the rate number but understand that I do the rate a number of times? So if something happens at a rate, a bullet's fired from a gun, 1 per second. All I'm going to ask, if I want to know how many bullets is there, how many times did the rate happen? How many seconds? And I could make it a half second. I could make it 1 per every half second. I could make it 1 every millionth of a second. I can make it any portion of time. And I'd still just say all I need to know is how many units of time happened at that rate. All right. Gary believes 10 meters per second, 10 meters divided by second squared means the 10 is squared. Yeah. No, that's not how it's written, okay? So if you want to write 9.8 meters per second, okay, like this, I don't have a problem. But that's not how you write it. you put a square on the rate, which is probably what he envisions will propel him to a Nobel Peace Prize. No, it's not a peace prize, frankly. But anyway, fame. Yeah, no, I'm not going to get it because I'm going to be dead before you morons have to admit, oh, we suck. There'll have to be a we suck holiday just in my honor, just to sort of pay back in some sort of homage that, oh, gee, something so obvious and we couldn't figure it out. We couldn't figure out they made a mistake 300 years ago because they followed some little kooky religious kook, all right, and came up with some nonsense that was completely unnecessary. Again, Newton had just written a book explaining how everything works, and all his answers were goddamn right. And you assholes decided, oh yeah, let's go with the guy who said no. Too stupid. That's how far removed from understanding he is. Yes, I'm very far removed from understanding how you take a rate and square it. There's absolutely no reason to do that. All right, he fractionally wrong. He's fractionally wrong about everything he talks about. So, I mean, that's just so idiotic a kind of statement to make. So, I'm perfectly right about the fact that the Young double slit experiment does not in any way accurately depict a double slit experiment. So, I mean, I could go through the whole list, but anyway. This asshole knows nothing about physics. Again, all he knows is that he has a huge, big, giant problem, which is I have more penis than he has. Anyway, Mofao, whatever. Have you heard his ramblings on law, economics, and politics? See, this is a guy who lies about everything you say, okay? So, if you say they should lower the age of consent, he's saying you're a child molester. Yeah. You're defending child molesting. Okay. Child rape, child abuse. Because you say they should raise the age of consent. All right. Okay. His internet presence is whatever this is, Prestilan. It's the same as someone who can't read whatever this is, kanji, telling the Japanese their way of understanding kanji is wrong. What the fuck is this shit? Who the hell cares? Oh, how hilarious. I'm sure everybody has a conversation sometime in their life about Kenji. Anyway, everything he utters is self-contradictory, ignorance, lies. Okay, and you can't produce a single fucking piece of evidence. You can't, a clip from a physicist, anything. You can't produce one single shred of fucking evidence on your side. Except his advocacy for CP. So again, he's saying that's child pornography. I'm not advocating for it. I'm just saying that once you have this stuff that's already been produced, if you can satisfy somebody who might hurt a child by letting him do it virtually, I'm saying yes, let him do it virtually. Yeah. I'm saying that's smart, in my opinion. It's smart to prevent harm. And I'm saying, I'm making the assertion that you'll prevent harm that way. All right, where your draconian nonsense about how I must somehow make it go away, covering your eyes and covering your ears, and what's the other thing? Covering your nose, you can't run away from the subject. That's all you want to do. You want to run away from a reality. And brutality against women. So that's just a lie. Okay, this is a guy who said sometimes they deserve it. His mother deserved it. That's what he said. She asked for it. So fuck this guy. He's not an advocate for women. He really thinks that women ask for it. Yeah, he's been remarkably consistent with those over the years. Yes, I've been consistently against brutality against children. I've consistently pointed out that even if you have those desires, you have to find some other way to satisfy them besides exploiting, a minor, somebody who isn't mature enough to involve themselves in relationships with adults. So I've made it very clear over the years what I'm advocating for. And this liar is implying I said something different, because in one specific case, I'm saying, yes, if the child porn is already produced and already out there, there's no point in running around trying to burn it all. Okay, too stupid. Don't remake the movie. Don't force somebody to remake the movie by burning the old copy, right? So if you have a classic like On the Wind and all of the copies are destroyed, well then aren't you encouraging somebody to make a new one? Dumbass. So what a puke. What a fucking puke this human being is. Just a disgusting sack of shit. Lie, lie, lie. That's all he stands for, and that's what he will be. Again, all right, instead of my Nobel Prize that I won't get, all right, because I'll be dead, please piss on this fucker's grave. All right. The Japanese people are supposed to have honor, so if you have any honor, all right, you'll make an example of this fucker and create deterrence to future assholes by basically putting his ugly, disgusting, rotting corpse in a pillory. Okay, and just let people walk up to it and piss on it. Don't be this asshole, should be the message. This shit talker who knows nothing about the subject. He has done no physics research. He has no physics knowledge. He just knows he hates me. And that's all he's got. And that's all this little Despar puke is about, too. It's the same kind of pukey little thing. He's got a little ego problem. You know, who knows what the exact problem he has is, but it's some sort of little fucking problem. Ugh. Humans. Alright, now, should I do anything else with this video? There's not much here, right? Not much. Alright, well, I guess we could see if there's anything from the other turds, but there likely isn't. Then I could just draw it again and again and again, and I could just ask somebody else to draw how gravity works. So I've asked them to draw how a lever works. They will not do it, okay? Not one of them will draw a lever and explain how it does this 1.4 thing, okay? So they just won't do it. Because fuck, it doesn't happen. Yeah, that's the easy reason why they won't draw it, is because no, that doesn't happen. Too silly. Alright, so nothing from the Gosling, nothing new from the Dispari. Let's see, what else is there? I could see this Michael Falwell asshole, but not likely he's done anything. No, he's still got his little rolling experiment. Let's see. There's really nobody else worth clicking on, right? Yeah, no, nothing. Brozo didn't do anything, right? Alright, nothing. Okay. So, yeah, I guess I'll just draw it again and again and again. That's what we'll do. I'll just sit here and draw the same thing over and over and over again until somebody makes a counter argument that somehow points out where I made my error, where I didn't understand what really happened. Okay. Because something magical really happened. Alright. So, they say, you know, that's all there is what they say. Okay. So, they say that distance is all that matters when you're lifting something or when something falls in gravity. And obviously, as I've pointed out, the only thing that matters is time. So we know that if I want to get twice the velocity, okay, I have to go 4 units of distance. Okay, this is not drawn to scale, but whatever. All right, and what I'll have, okay, when these, I should have drawn this way down here, right? Yes. Okay, so I go 1 unit of distance, I get a weight. This has 1 weight. If I go 4 units of distance, I get 2 weights. Okay, so I can't go I can't just drop it from here. Okay, if I drop it from here, that won't work. I'll get 1 point something, but I won't get 2, okay, in terms of the weight. And I also won't get twice the time. So if I drop it from here, it won't take twice the time. It'll take a lot less than twice the time. So even though I dropped it twice the distance, it won't be twice the amount of time, because it's obviously going to be going a little faster and faster as it falls. It gets faster and faster because it's adding to the acceleration. The previous acceleration is kept as a velocity, so the previous acceleration is turned into a velocity, okay, and then you add an acceleration, right? So the velocity just keeps getting bigger. I add an acceleration, the velocity is this much. I add another unit of acceleration, and the velocity gets this big. And then I add a unit of acceleration, and the velocity gets this big, right? So it just increases the velocity. All right. So it's to go twice the amount of time falling, okay, twice the time, 4 times the distance. So this is 2 units of time. And in those 2 units of time, this portion, okay, will be 1 unit of time. And this little bit, right, which is the same as this bit, this is where I'm going half the speed here. So way up here is half the speed. Way up here. Okay, I'm going half the speed. Because I only gained I got 9.8 here in velocity, and I only got 9.8 in this whole giant section here. So per foot, I didn't get the same amount of velocity. Per foot, I got a lot less velocity. All right. So and it's twice the velocity here. This is twice the velocity here, and this is 1 velocity here to go with the 1 weight and 2 weight. Yeah, see the 2 numbers. So it's twice the velocity, twice the weight, twice the time, and they say it's 4 times the energy. Where did it get the 4 times from? It only got 2 units. It only got 2 units of acceleration. 1 unit here, right here, okay, and 1 unit here. 2 acceleration. A plus A can't equal 4A, right? 1A plus 1A can't equal 4A. I didn't gain 4 units of acceleration. I only gained 2 units of acceleration, 2 units of force. You could just use the word acceleration and replace it with the word force. A force has to cause the acceleration. It's a force. You got a certain amount of it, and that's all you've gotten. All right, now I've compared that to the simple rolling argument. If you roll an object on a frictional surface, the fact is that so if I have a 1 velocity object here and a 2 velocity object here, all right, that this 2 velocity object will go 4, okay, and the 1 will just go the 1. And so the friction, the stuff that's taking the energy, so that's how you're measuring the energy, is by letting it run out, let it run into the surface. And the simple argument to be made is this doesn't prove 4 times the energy, because it wasn't 4 times, it wasn't the same friction per foot. So because you're going to end up with the same kind of weirdness. The 1/2 the speed will be here. Okay, 3/4 down the track is where you're going to go 1/3 to 1/2 the speed. So as you roll this section, this whole section here, okay, gravity was pushing you down with the same amount of pressure, all right, as in this little section. So you felt the same number of little hits. If I could just turn it into little bits, the same number of bits hit you here. Let's say it was 5 over this whole period. Well, the same 5 hit you here, because it's 5 units, because it's 1 unit of time. So the same amount of time means the 5 was compressed into this, very fast frequency, where this was a really slow frequency. The same number of bits, but spread over a much larger period of time. And so, but this is the giveaway, the 1/2 here, the 1/2 here, huge giveaway. And they know this for a fact. I'm just saying it's a fact, okay, an absolute fact. I drop it 1 unit of distance, it will be going 9.8 meters per second. It will travel 5 meters, okay, after 1 second. And we know it does exactly that here, Okay, because we're not changing this. We're not making a significant change to the 9.8 meters. So we're going to have exactly the same thing here. We're going to have 5 meters and we're going to have 9.8. Okay, meters per second of velocity. And we know when it hits, it's going to be 19 meters per second velocity, 19.6. So we know, okay, that only doubled the velocity. We know that's a fact. All right, and we know this distance is going to be, much bigger than this distance, the 5. It's going to be 3 units of 5. 5 for my new unit, and then 10 for the 9.8 meters per second. This is the 9.8 meters per second part I gained here. Okay, so this is the only new added force, is this little 5. That's all I got from the new piece of force. The new piece of force only gave me this 5, but it's going to give me 15 down here. Okay, 1, 3, 5. It's going to give me 3 units of free energy down here. Anyway, of free velocity. Velocity you don't have to earn again. You don't have to start from 0. So you're accruing velocity as the force affects you. So they won't do this simple diagram and explain why this is the halfway point. Okay, this is where it's going half the speed. And so somehow we're supposed to believe that they're 4 times the energy is somehow disproportional. I don't know. That somehow it's not 4 times the unit of force. Well, where could it be possibly, where did you do that? How could you possibly say that this is per foot? Okay, the energy went into the ground here is the same, is different, it's 3 times as much energy that went in here. Have they done the experiment showing that this is 3 times the energy went into the ground here as that went into the ground here? Have they shown that in any experiment ever? No. And the simple argument is, no, it's 3 times less. Okay, per foot. Per foot, it's 3 times less energy going into the ground. The faster you're going, the less friction, the less contact, and the less energy you can lose to the ground. The faster I go over a scale, the less I weigh. Okay, so, we've already seen the huge perversion of this simple experiment. You have a scale that has a certain dimension to it, okay, and it's just going to measure how much you weigh. And the simple argument is the faster I roll something, let's say across that scale, okay, as long as it starts to get fast enough to break the fact that I have a gravitational weight. All right, obviously if I take an hour to go across, I'm going to weigh the same as if I take 2 hours. But there's a point where if I go fast enough, I start weighing less and less because I'm not on the scale long enough for gravity to do its work. And that's the simple reality. So yeah, you go slow enough, friction is all the same. But you go faster and faster, you change it. And you start applying less and less weight because the force of gravity is time dependent and it doesn't have enough time to push your mass into the scale. And so you're going to be making less contact with the surface. Less pressure will be applied on the surface because you won't be in it long enough. You go fast enough through the rain, very few raindrops will hit you. You go fast enough across a paint sprayer. There's a sprayer that's spraying a constant amount of paint. You go through it really, really faster you go, the less and less paint you get on you. It's just a fact. So if you could possibly go the speed of light, you might be able to get through without even hitting any of the paint particles because they're going so much slower than the speed of light. So you might be able to pick a path where you could actually get no paint on you, theoretically. Where there's actually an empty space that you could travel in a straight line and not be affected by the paint. Possible, I don't know. I don't know. It has to be, just depends on, I guess, how dense the spray paint is. But anyway, I'm taking the analogy further than is useful in this case. So yeah, we could just draw that. So this is a simple way of analogizing gravity. Okay, they say it's a pull thing, and it obeys the inverse square law because it's a pull thing. Okay, just by accident it does. Okay, so sort of because it's let's see, it's pulling in all directions, equally. So that's the whole point source argument. So the inverse square law is basically just made out of this idea that if you pull consistently from any infinitesimally point, that you're basically pulling things in 2 dimensions. So you're pulling this way, and then you're pulling this way, okay? And you're causing things that are out here big, and you're causing them to shrink to get to you. So that's the pull theory. Now, obviously, it works much better as a push theory, okay, in the sense that the sun radiates photons in the same kind of way. And so as the photons leave the point source, the little sun, okay, they're going out, they're traveling. So they start right next to each other. And they're not going to separate just in this dimension, okay? They're also going to separate in this dimension. So they're going both dimensions of separation. And so that's why it's a squared function, is because it's 2 dimensions that are spreading. You're spreading in this dimension, and you're going to spread in this dimension. So in both dimensions, the little particle is going to get further and further from each other. So it's a, people draw it as a, literally draw a square, and you can sort of understand that you're separating, okay, in this volume. The volume gets bigger and bigger as you go out, okay. All right, so what was I going to do with that? Oh yeah, I'm just going to make the particle argument. So you can think of them as particles. Particles would do exactly this. They, it fits very well that if you understand them as little particles flying off of the sun, and that they're separating in both dimensions, you can understand why it gets harder and harder to hit, the surface area, the volume they're hitting. So that's what the square means, is it's a volume. It's not a line, it's a volume, because it's got 2 dimensions to it that you're spreading in. All right. So that's the simple analogy, is just that gravity is a pushing force. And so I'd like them to explain why this analogy doesn't work. And that it's just bits, okay, of energy. And there's more of them going down than are coming up. So the Earth is blocking, in some sense, using, okay. So you have 5 coming down, let's say, and only 4 coming up, and you're an object in here. And so the simple 9.8 thing is the difference between how many are coming down versus how many are coming up per second. And so it's just really is a literal quantity. You could just say it's 10 bits. Okay, 10 bits, and you could say per any unit of time, and you could just know the rate at which more will come down here. So if I go 1 second, I could say this one is 10 ahead of this. So I got 10 more every second. I get 10 more hit me this way than hit me this way. And that's my acceleration. That's the differential that will create acceleration. And you can understand that, okay, I get hit with the 10. Now I have the velocity, so I'm going to keep that velocity. So whatever the velocity is, every unit, I get that velocity for free. Okay, so I don't have to pay for it again. I did it, I'm moving, I'm going to keep that velocity unless something opposes it. There's nothing opposing it, so I'm just going to keep it. Now I'll just keep doing that 10 over and over and over. In this case, 5 meters. So every second I get that one for free. And then all that's really going to happen, so in the first second I got this one. In the second I have the free one, okay, plus the new one. All right. Let's see. Yeah, see, you have to go with the velocity. So the only thing, the trick is your velocity is 10. You only went 5 meters, but your velocity is 10. So this 10 arrow is the free arrow. All right. So you have a 10. All right, and then you're going to get another acceleration, okay, which is going to do the same thing, which is going to create another 10 here. So you have 2 10s here built in, and then you're going to just add a 5. All right, and that's what you're going to keep doing. So every time you add the 5 meters, you're adding 10 in velocity. So the 10s just accrue. So you got you got 5 here, okay, in terms of meters, and you got 15 here in terms of meters, okay, and then the third thing is going to be 25. Yeah, I have to think about it. Yeah, you're just adding 10, you're adding 15. That shouldn't be this complicated. And 3, this is 3 times, and this will be 5 times 5. Yeah, 25. And so it just goes like that. That's all you're doing. You're just saying the velocity I acquire from the unit of work. So the 9.8 you could say is the work. So you put some work in. Okay. The benefit is the work created a velocity. So you're going to have, now you're increased your velocity. So you're going to get a velocity portion forever. So and the velocity portion is this 10 velocity. So you did 5 work in terms of, we went 5 meters, you got 10 in velocity, and that's what you're going to get each second. And so each second you're just getting a 5 plus the 10, because you're going to go 10 meters faster, and you get to keep everything you already have in terms of the velocity. So all the old velocities will be kept. And so it just keeps increasing. 1, 3, 5, 7, 9, just keeps doing the odd number thing. So you just keep adding, but you're only adding 5, work per second. But you're keeping the work you did previously. You're keeping the product of that work. But there's only 2 units of gravity. 2 units of time, it's only 2 units of gravity. You can't possibly say that converts into 4 units of energy. It's only 2 units of force. 2 units of force cannot be 4 units of energy. It's just stupid to think so. Frankly, just really stupid. Alright, let's see if we have any comments, and then we'll get the hell out of here. It's all quite discouraging. So nothing from the guy who's supposed to sometime late this week. So we're Thursday. So hopefully he'll have his video up in the next couple of days, and then we can argue with a real physicist. Which, hopefully he'll provide some kind of real evidence and not just mush. Look, I can divide by, blah, 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 and then, all this mushy, fake little cruddy mathematical crapola. No evidence, just crap. Contrived crap. Ugh, can't even get my cigarette to work properly. Alright, so let's see what mush there is here. There's Bruce again. You collected 9.8 units of momentum per second. Well, in the first second you collect 9.8. The second, you're adding to the 9.8, so you got 19.6. You collect 9.8 joules of energy per meter. So again, it's just absolute nonsense. You don't. Just as in friction, you don't lose it per meter. How can you go half the speed after just 1/4 of your voyage? So after 1/4 of your voyage, you're going half the speed you will ultimately go. How can you say you got the same amount of force, quote unquote, or have the same amount of force in those 2 halves? You don't. Okay. They are different things. Well, whatever. That's useless. Because half the speed is only 1/4 the energy, says you. I'm just saying there's absolutely no reason to believe that's true. There's just nothing that says that's true. It's just you saying so. There's no logic to it. It's 2 units of gravity. Do you admit it's 2 units of the force? 2 seconds is 2 units of force. somehow 2 units of force equal 4 units of energy. Half the speed only gets you twice the height. Well, that's a lie. So that's not true. So show me any experiment that comes anywhere. Oh, he retracted that one. Okay. Yeah, that's not true. Twice the speed gets you 4 times the distance. Because you're only fighting 2 units of fucking gravity. Again, how it's so obvious. Why does half the velocity get you 4 times the distance in gravity? Why? Because it's only 2 units of force that you're fighting. That's all you're fighting, are just 2 units of force. Let's understand, the numbers get crazier and crazier. The further you go up in space, the more miles per gallon you get. Your gas mileage goes way up the faster you can lift off. Half the speed only gets you 1/4. You already said that. That's your Jesus theory, okay? That's not evidence of anything. That's just you saying so. There's no evidence of this. Oh, I mean, you're saying, okay, so you're just saying it backwards. Half the speed only gets you 1/4 as high. Right, it's only 1 unit of time. The first unit, look, it's 1, 3, 5, 7, 9. We all agree on that, right? So obviously it's idiotic to compare the 1 with the 9 or the 1 with the 900. Why would I do that? I'm obviously gaining a huge amount of distance by the time I get to the 9 or the 40 or the 400th velocity. I'm gaining a huge amount of distance for a tiny amount of force in. The force in doesn't mean anything. It's like, look, I've made the analogy. I mean, do you really think the meteor crashing towards Earth, it comes in at, say, 25,000 miles an hour? Do you really think the 2 seconds it's in Earth gravity are going to add anything to its velocity? No, it's not going to mean anything. It's going to go be 25,000.68. It's going to gain a tiny amount from Earth's gravity. What it's doing, it's the velocity it already has is the velocity that's going to do all the damage. The gravity is going to be meaningless. What it gains from gravity is going to be nothing by comparison. That 9.8 meters per second is going to be nothing compared to 25,000 meters per second. We just go round and round. I just don't know why you can't break the gravity down into units and just understand it's a unit of energy. We're putting it in per second units of energy. You're only adding 2 units of energy to drop 4 times the distance. It's only 2 units of energy. Same thing opposing. If you go 4 times the distance, if you gain a velocity high enough to get to 4 times the distance, you're only going to spend 2 units of energy. You're only going to have to fight 2 units of gravity. All right. Well, there's no real conversation with that statement, frankly. I mean, it's just ludicrous. Obviously, Newton, Descartes, and Galileo thought of energy, quantity of motion, as exactly that. That's energy to them. If they had the word energy, they would call the quantity of motion energy. So you can say somehow you've put momentum in some other category. Okay, it's all of a sudden not a quantity of anything. It's not a quantity of anything meaningful. Doesn't mean anything, frankly. And I'm going to say bullshit. I don't know how you conceive of the universe as being rational, frankly. If you sit there and say, let's just forget about the concept of the mass and the velocity, even though it's central to your own theory, and instead pretend, okay, that there's free energy. I can't make it into anything other than a free energy theory. There's no way to fix it. If I conserve the momentum and I crash little things going fast into big things, I'm going always, every single time, I'm going to lose energy. And every single time I do the opposite, I'm going to make free energy. So I can't make any sense out of it. We're back to the gun and the bullet in space. I mean, I can't make any sense out of it. You say the bullet has 2,000 times, or let's just say 1,000 for the sake of argument, 1,000 times more energy than the equal and opposite reaction of the gun. Okay? You say it's 1,000 times more energy, and yet you concede it doesn't do anything. And then you tell me that momentum is a different concept. Well, I'm saying that's the concept. The concept is causing action in the universe. And you're saying your theory doesn't cause action in the universe, but you're going to call that energy. I'm going to say if it doesn't cause action in the universe, it's not energy. Your definition of energy is just retarded. We have an energy detection device called a scale. Exactly. 2 units of work, 2 units of weight. Momentum is energy. Okay, this guy's the guy agreeing with me, I guess. Momentum is action in the universe. So I don't know what you want to call it. Movement of matter in the universe. I mean, there's no other... What other description of energy are you going to have besides movement in the universe? And you're just claiming that when something light moves, retaining conservation of momentum, that somehow it has magical extra superpowers. And when it's a big thing, it's weak and feeble and fucktarded. Yes, it's one of my quotable quotes, really. I mean, that a scale is an energy detection device. I was probably the first person to say that. Probably. But no, it's crazy. It's a crazy theory. Crazy. Woo, crazy. Conservation of momentum. Crazy theory. Yeah, I haven't been out yet today. It was bad, but I spent the whole day working outside, so... As a previous smoker, it's like, oh, this is like a half a cigarette. It really isn't bad. It was kind of almost, except for the headache it gave me, it was it was nice. Yeah, it was nostalgic. So I sort of enjoyed the smell of real smoke, because I don't do that anymore because of because the crazy people, the prohibitionists like Godfrey, tax other people's vices, not mine. The air quality, okay, I already did that. It's off the subject. I mean, I really do want to stay on the subject, frankly. That's why I have videos on, graph science. I'm not really doing the science of whatever the fuck, whatever the fuck caused this bizarre, well, there's whole weather. I mean, it got to be like 40 degrees out yesterday. It was just so, you're just like, what the fuck? So it's like one of these Alberta Clippers or something. I mean, this fucking Canadian air drifting down here is so annoying just because it's cold. They said it was supposed to be something like 78 degrees, and it really was below. I mean, it had to be like 65 in the afternoon, and probably was because there was no sun. I mean, everything was orange. Everything looked orange. Because the sun was getting just blocked. All the scatter was happening and the frequencies were getting used up. I suppose it's to some extent you have to blame Compton scattering, because you're probably changing higher frequency light into lower frequency light because you're hitting so many particles. Did the spore unit help clear anything up for you? I mean, are you just retarded, or are you like you have double Asperger's or some other kind of thing? I mean, I played the video in the beginning of this video, but anyway, of course it clears nothing up, okay? It's this whole idea that acceleration, somehow this unit of energy, this force that you apply that causes a change in acceleration should be squared for some reason, is just fucking idiotic. There's no reason to do it. Per second is baby talk. It's absolutely silly. 60 miles an hour per hour. No one says that because it doesn't happen that way. You don't sit there and say the rate per the rate that it happens, the rate happens. You don't bother saying that. The word rate already solves the problem. You already know it's a rate. And you already said per second. You don't need to say it a second fucking time. Oh, God damn it. Yeah, my fundamental problem with it is the very idea that this division thing is giving you any kind of answer anyway. It's a meter per second. The number. The number is representing how many meters per the unit of time. Why do I need to square anything? Yeah, well, it's not my fault you missed it. Well, it's clear you people are affected. I mean, I go to all this trouble to write it down and show you. Where's the square part? Okay, I put in 1 unit of time, which means, okay, 1 unit of time, I get 9.8. I put in a second unit of time. What am I getting? I'm getting just 9.8. 9.8 plus 9.8 is just 20. So, 19.6. So, what's wrong with all that? It works just fine. Newton got right answers. That works. Why the fuck do I need to per second anything per second? Why do I have to add another per second? What value does it have? Except to create convoluted math. You understand there's 2 different rates, right? No, I don't understand any of that. There's not 2 different rates. Well, okay, he's saying there's velocity and acceleration are 2 different rates. Yes. And the rate of acceleration is a unit. It's a one thing. It happens per second. It doesn't happen forever. It doesn't happen any of that stuff. It only happens once, where the velocity accrues. So the two things really are fundamentally different. The velocity is the permanent thing, the real thing. The acceleration is a change in the real thing. I said this to you yesterday, okay? It didn't mean anything to you. But isn't the velocity the real thing? The acceleration is a change in the velocity. That's all it is. It isn't a real thing. The velocity is the real thing. And all you're doing is saying, for one moment of time, I'm going to change. I'm going to make an effect on the velocity. I'm going to distort the velocity. You don't do it over and over and over again. You do it this. I did this. I changed it. Okay? And I can change it again a second later. And I can change it again a second later. Okay? But what am I really changing? I'm just changing the velocity. I'm not changing anything called an acceleration. I'm changing the velocity. The velocity is the real thing. So it would be helpful to specify which rate you are referring to. I mean, just too stupid. I've drawn it. You can't get it any simpler. They won't draw it, okay? So draw it. Draw your theory of how motion happens in gravity. Explain to me how there's 4 units of energy because there's 4 units of distance. And it's not just 2 units of energy because it's only 2 units of time. Just explain that distinction. Why you are paying attention to distance when distance is a measure of velocity. It's not a measure of acceleration. Because the velocity is the permanent thing. The acceleration is the one event thing. I would say the position is the real thing. I would say the position is the real thing. The velocity is just the rate of change of the position. So you can say that all you want. I'm saying it's obviously a quantity of motion. It's a property the object has. Okay, you can pretend it away in some way, but I'm just saying objects have it as a property, their velocity. It's something they possess. That's why quantity of motion was more literate than I ever thought it was, because that's what it is. It's a quantity of something the thing possesses. It's a force. The earth moves around the sun because stuff hit it to make it move around the sun. Okay, it didn't get the velocity from nothing. It got the velocity from something. Interactions with things that had the quantity of motion, and the earth took their quantity of motion. So again, all of this aggression from this, this Bruce guy, he's just going to keep trying to defend something. I point out how he has no evidence. He has had 350 years to compile evidence. They don't have any evidence. Nothing showing anything close to it taking 4 times the fuel to go twice as fast. Nothing. Nothing. And he just keeps on saying, there's a reason I'm doing this. I'm preserving the rationality of it. There's no rationality of it. Momentum worked perfectly fine. So show me the place where momentum doesn't work and kinetic energy does. And the only place you'll show me is positron. You'll show me some place that's abstract. You won't show me anything in the real world where you can show momentum's getting the wrong answer and kinetic energy's getting the right answer. You're just challenging me with Jesus is God, Jesus is God, Jesus is God, F equals ma, F equals ma. Newton said so when he didn't. Yeah. You're not challenging me with anything, okay, to the logic. You're not explaining to me Well, it's clearly 3 times the distance, okay? You're only going half the speed, and you only went this far. You're going half the speed, and you went this far. And then you're going twice the speed after you go all this huge distance here. How can this be linear? Well, it's obviously not linear. It's obviously not the same thing per unit of time. This unit of time gave me this big giant distance. This unit of time gave me this little tiny distance. We know the force isn't doing that. The force isn't 3 times more powerful here. All right. Let's see. I'm not calling you names. Again, I don't care. If you lie about what I'm saying, then I'm going to be pissed off. Saying your ideas are baby talk. I'm saying it's baby talk, okay? I have a right to make that judgment, so that's my accusation. I'm saying you're belligerently stupid, okay, because you have 0 evidence, and you just keep fucking aggressively defending. I mean, that makes you an idiot, okay? When somebody aggressively defends a theory for which they have no physical evidence, and then just plays math games. Look, I can change this symbol, and I can do this symbol, and I can multiply the units instead of real numbers. I'm saying that's baby talk. That's just cheating all over the fucking place. That's a distraction. Are stupid even though you do that to me. Yes, and for good reason. You've repeated the same arguments over and over again. I keep pointing out, well, velocity is the real thing, and all you're doing is changing the velocity. The velocity is the only real thing. Acceleration is synthetic. It's not made out of a real thing. It's a change in the real thing. You don't concede any of my arguments or counter any of them. You're dropping in gravity. You drop 1/4 of the distance and you're going half the speed. Do you agree? In every circumstance, so we just take every circumstance to just say doesn't matter how many seconds it is, doesn't matter what the time units are. 1/4 of the voyage, and you're going half the speed in gravity. So if gravity's propelling you 1/4 of the voyage, you're already going half the speed. Doesn't that mean it's not linear? Doesn't that mean that calculating the distance would be irrational? Because obviously you're not getting the same amount of motion per unit of distance. You get the same amount of momentum per unit of time. So again, it's mv. So that means it's the same amount of, you're saying it's the same amount of the mv squared is different because you're squaring the velocity. So saying that doesn't mean anything. Saying anything like this doesn't mean anything because your theory is made out of momentum. You're just squaring something for no good reason. Oh, fuck. And the same amount of energy per unit distance. And this is the same amount of energy per unit distance. No, it isn't. So that's the nonsense part. You just made that up. All right. We just disagree on the definition of energy. Well, whatever. I don't know how we could disagree on what energy is, so I don't know what you're talking about. I mean, it's mass moving is energy, right? So you make your theory out of my theory. So don't play a game that somehow you can disqualify momentum because you make your bullshit out of momentum. You put the funny hat on momentum. Okay, it's not like I'm putting a hat on your theory. You're putting a hat on my theory. You're putting this useless, silly hat, this stupid little spinning propeller thing on top of a perfectly good theory. I'm just saying you define energy to be the same as momentum. So do you. Your energy is made out of momentum, mv. All right? You just do something silly to the v for no good reason. And I just explained how it can't be linear. So to some extent, there's no point in having the conversation. Twice the time, twice the velocity, twice the weight. Now, if you could show it 4 times the distance equaling 4 times the weight, you'd have an argument. But you don't have that on your side. It's not 4 times the weight. So how can you say force times distance? Well, so again, the momentum is entirely useful when you don't want to use your silly theory. When your silly theory fails, you go back to the right theory. So that's just what a cop-out. Oh, shit. Momentum is entirely useful when, well, our theory doesn't work. Well, it's an important argument, frankly. I just don't, you're not persuaded by any facts. So the fact that Newton won the argument, okay, so for the first 30 years of the theory, the Newtonians won. And they won by pointing out that levers become free energy devices. Okay, that was one of their arguments, okay. It doesn't work. If they use it and redo Newton's equations with 1/2 mv, with mv squared, they're not going to get right answers to how things move in the universe. So it lost decisively. Okay, then there was a disciple of Leibniz, okay, who still was around. Let's see, it was probably 60 or 70 years later. Okay, so now we're at 1740-ish. And he tutored in the 1720s a woman, Madame Chartelet. Deschartelet or whatever the fuck it is, and then she was very wealthy, and so she was she was doing the science thing, so she would publish under fake names and all this kind of stuff, but she was really interested in science, created a library, all of this kind of stuff. She thought Newton was brilliant, by the way, which is ironic. Her dying moments were doing a translation of Newton. So it wasn't like she was an anti-Newtonian, but she just didn't get that this living force thing was really an attack against Newton. So anyway, she was tutored by this guy who was just basically somebody with an alternative theory. I mean, I'm not gonna call him a flat earther, but okay, to me he's a flat earther. And so she got all caught up in it and thought this was a real thing because, yeah, it is 4 times the distance, and things do roll 4 times as much. And you can do a couple other experiments, like if you calculate how far you put in an energy into a bucket of sand. Well, if you put the energy in fast, you'll get pieces of sand that go very far. And if you put the energy in slow with a heavy object, sand doesn't go far at all. But a lot more sand moves. See, that's the catch, right? So it's the bowling ball argument, right? The heavy ball lasts longer than the 8-pound ball. The 16-pound ball is more durable in its distribution of energy. And that's the difference. So, yeah, it loses to the 8-pound in the beginning, but it beats the 8-pound in the end. And those two things will end up equaling each other in terms of the durability of the energy. So one gives away a lot of energy quickly, one gives away a lot of energy slowly. So, I mean, but it's the same total amount of energy. So one looks like it's more energy, but stuff, if you just measure how far a grain of sand went, well, then you're going to say the faster thing wins. But if you're going to measure how much sand actually was moved, how many feet, then they both have the same. All right. So anyway, those kind of goofy experiments. So they dropped round things into clay, and they found that it has the same kind of phenomenon, in the sense that the deeper you penetrate, there's an advantage, because now you're taking advantage of pushing the clay sideways rather than pushing the clay down. And so the deeper you go to the halfway point, there's an advantage. So if you can get in a little deeper, you'll have to do less work. So the fact is the twice as fast thing, okay, ends up penetrating or displacing 4 times the amount of clay. But it's the same argument that could be made about rolling things. You don't get the rolling argument. I mean, all these arguments made, you don't get the rolling argument even. That the fact is that the faster I go across a scale, the less I am going to weigh. You don't believe that's true? The faster I go across the surface of a scale, the less I can weigh. I can weigh almost nothing if I go fast enough across the scale. And that's a measure of the contact, the friction. And so it's essentially a measure of how much energy I can possibly give the scale. I'm giving the scale less energy per inch. Doesn't that say to you that distance is the wrong way to measure? That we're using distance to extract the energy. We're using distance, creating a friction, creating a dampening leak. We're trying to leak the energy out of the object. And we're doing it through contact. And the fact is, the faster I'm going, the less contact I'm making with the surface per foot, per meter. So obviously I'll travel further because I'm making less contact and I can leak less energy because of that lower contact. Like if it was a voltage, you could understand that if the contact isn't very good, I can't get the watts into the other conductor because I'm not making enough contact. You can't understand those arguments, and you can't understand how, well, that is a real problem. I mean, I should have a great answer for that, and you're really not going to have a great answer for that. Maybe he left. I mean, to argue that this doesn't need to be argued out is just saying, you're settling for no answer, that sucks. I mean, you really should be able to defend your theory. Now, if I was the head of the Science Foundation, I would defend my theory, okay, and all these experiments would be done precisely. I mean, it just is kind of funny because, you could just do the simple analogy. They really don't think that, scales are just going to measure it. A 5-ton train going 10 miles an hour, it's going to weigh the same as a 10-ton train going 5 miles an hour. They're going to weigh the same. And when we do the experiment, it's, it's going to come out my way if it's done right. All right then. Well, we'll call it a day. I guess that's it. He must have left the building. Fine. Whatever. Dropping things. Where the hell did it go? Better not hit my hard drive. Anyway, close but no cigar. Did try to hop into the computer though. Anyway, all right. So till the next time and such and so forth and whatnot. I have to actually leave to leave. So. Humans. Belligerently stupid. That's all you call it. Like I said, when you have no evidence, you really shouldn't, tell other people they have to believe. It's just too silly. So, yeah, I guess I could, well, I can hit